Okay. Now, can you see my screen, everyone?
Yes, sir.
Yes, sir.
Yes,
Yep.
sir.
So, shall I start now?
Yes, sir.
Okay. So, hello, everyone. Thank you, Saloni, for this nice introduction. So, now today I'm going to talk about two blockchain algorithms for in intelligent vehicles. So, what's this? Before starting, I'm just believe that everyone has some background about what is the blockchain, right? Anyone?
Yes, sir.
At least,
Yes,
guys,
sir.
you must to respond it. Otherwise, I'm just gonna read out my slides, and it is not gonna useful, right? So, I'm gonna interact with you guys to talking to with this way. Otherwise, if I'm just going to slide by slide, so it will have some confusion on if you not gonna be get it anything, right? So I have just believed that everyone has some background about to blockchain technology or intelligence cycle. If not, that is also good. These things I'm going to talk about to the very simple and basic way to how to this blockchain technology is comes and how to this gonna be changing our lives. It is not only for the like in starting blockchain is started for the cryptocurrencies, right? Bitcoins and those cryptocurrencies, like most of people are finding those things uh, as a financial point of view. So bitcoins and those cryptocurrencies, they are work on the blockchain technology or blockchain algorithms things, and that is the basic four basic things like decentralization, smart contracts, consensus, and cryptography. That four things, this whole blockchain technology or blockchain algorithm, even anywhere we talking about to this blockchain structures, they are believe on these are things had mentioned in this only for these four things. Whatever the now where like is coming blockchain is almost now is coming to more than 10 years is coming on, and it is started to thinking to how to use reutilize those blockchain accept cryptocurrencies things. So this work I had started from to 2016 to we are start thinking to how this blockchain technology can be changed to be used some other applications. So this is my first application when I work or this blockchain in intelligent vehicles. Now I come back to the intelligent vehicles. Intelligent vehicles means nowadays our vehicles are also upgrading. Getting a more sensors, more technologies are added, and more even to giving the some computing power also they are using. And we are believing that is after within a few years, sometimes it comes to be a self-driving car, that autonomous cars, that is intelligence vehicles. So that we are trying to mix with those blockchain technology or blockchain algorithms with this our intelligent vehicles in advanced vehicles. So let's see, that is today's content. First, I'm just give the brief introduction or information about to the discussion about to the automotive technology and automotive technology, cyber securities, blockchain technology, role of blockchain algorithms in the intelligent vehicles. And after that, I give the one scenario, give that examples of those that scenario to how to use and how I had simulated this because we have not that much technology in advanced vehicles. So I'm worked about to the perspective of the self-driving cars, autonomous cars. So as of now, we have seen vehicles are improving, vehicles are adding the computational power and those things, how this growth are going on. So most of companies currently, big companies, they are focusing like Tesla and those, they're focusing about to developing the self-driving cars, but still they have the like something, once you are starting to develop something, you just focus about to just develop it, right? So but they have also, we need to think about to how, what is the vulnerabilities can be occur, and what type of challenges can be in the future, what type of challenges can be happen. So for that purpose, like security, as much as we are going to add the computational power and those things, so cyber security, that is the more effective and more uh, impact with this regard, the more we need to more secure things. So let's see first what is the automotive technologies are development. So automotive technologies are applications of knowledge about the self-propelled vehicles or machines. And automotive technologies are learned about to engine constructions, fuel ignition system, powertrains, brake, transmissions, electronic and diagnostic equipment, and more of the sensor they have adding those things, continuing is upgrading things. So this is the, can we see, this is the upgradation of the automotive of vehicles, how to they are changing the environment, how to they are upgraded their vehicles, and they're coming to revolution in the vehicles automotive industry. So first they have started by the open connected platform and new legacy of the cars. Then it started to using the sensors, mass, they producting the mass differentiation in car services, where, and then it start to interacting the vehicles using those some satellites, and the music and those system is coming on the vehicles. And now it will be, so our current present time vehicles are somewhere between the second and third, between the here somewhere, not like environment traffic and in mobility, where traffic as an ecosystem, energy, environment and mobile technology, and sorry, not here, second and third, so still we have to improve a lot of things level. So fully connected vehicles, that is the our going to be talking, people are start talking about to the within a few years, like 10 years maximum, the full automotive cars are here. So that is the automotive technologies development. There is society of automotive engineers, that is SAE. They have defined J3016, define the classes of the this vehicles automations, levels of driving automations. They define in these sections, and they are believing that till 2030 the automotive technology will be fully autonomous surrounding us, and that is easily available for the common peoples to be using things. So they have defining the levels, the total 6 levels, 0 to 5. The first level they have only driver conventional. So the where vehicles drive manages all aspect of the speed directions. Level 2, they assisted the driver receives support for the specialized task. For example, parking, indicators, backlight, etc. Level 2, we have talking about partial automations where driver receive support for the copying predefined scenarios like ADAS, and like service traffic, jam in warning, avoidance of the following the some particular route like that. Then level 3, there comes to conditional automations where driver can be Linux of the control to automated system, but must be ready to the take back control, motorway, autopilot like that. So current time we are belonging somewhere between this level 2 and level 3. Our vehicles are. And level 4, there is a significant automations. There is a majority of journey may automate by some drivers. Intervention may be required, like urban motoring things. And level 5, that is the complete, talking about the complete automations. There's complete end-to-end journey without the driver interventions things. So this is the about to the development of technologies, how to going on. So but we are as a focusing about this type of development in our vehicles, but still they are not talking, you can see they are not talking about to what the happen when they have that much connectivity, that much in like computer connections or that much internet, and those things are going to be connected. So how, what type of security challenges can be possible, can be happened in those things. So automotive cybersecurity challenges, these are some challenges you're talking about to technical point of view. They have protection against the technical failures. They must to ensure possible solution must be ensure security and safety aspect in the context of the vehicle communication environment. Technical and IT security, there is a protection against malicious and manipulation and intrusion data of the informations coming on to receiving by the vehicles. Those things is manage the safety and security during the software development and upgradations. Quality attributes, let's talk about the end users, trust on the applications, and interconnected the computing platform, and security relevant the organization policies and processes. So for this type of challenges can be solved with the help of provide the trustworthy open automotive ecosystem and application stored from the end user centric perspective things. So these are the some challenges of in the security technical safety, security, and quality attributes. So there is a defined that, as we know, these vehicles have a we have another as a wireless network. We have also WANet network that is involved in vehicle communications, vehicle to anything's communicated on networking, connected connections or communications, or vehicle to infrastructure or vehicle to any things can be connected. Those things they have also like this type of some challenges. Like in vehicles, they design software and hardware for automotive cybersecurity to create the trusted platform to ensure the interoperability to confirm standard in automotive cybersecurity. So build secure communication environment to develop dynamic environment to be can be where vehicles can be dynamically or automatically or adaptively involved in the network and can we predict that what type of messages are useful for them, what is coming from the real nodes, or what is coming from the illegal, what is the modified. They can predict those adopted that any message to be based on their verification and validation things. That is a V2X, vehicle to anything communication security. Then we call to vehicle to infrastructure. Infrastructure means we have to ITS system, intelligent transportation systems, that vehicles are when transporting or transmitting to one place to another place going on. So they have also adopted those issues. They need to help like signals or getting the message from the path clearance, something some accident is happening, those things. So getting those informations, that is the also one vehicle to infrastructure security communications. That is the related, that is related with the services. So where to ensure secure architecture for connected vehicles to control the vulnerabilities pre and post threats and to allow user to use the services at low risk. So the target is securing content, authorization, authentication, message integrity, protect the privacy and data security of the vehicles and users, so on. So these are some challenges can be still in happen in the this autonomous vehicles or self-driving cars. Even though current time of cars, whatever we have as much as intelligent cars, as much as like we are using to so many sensors, so many things present cars, they have also this type of some targeted things, the challenges to be solved. So these are overview about to the basic automotive cybersecurity issues things. So next we talk about the basic blockchain, understanding the basic blockchain things. So as we already talked in the first slide that the blockchain is completely based on these four things: consensus, distributed ledger, cryptography, smart contract. So what is this? These things they are talking about to the blockchain is a type of digital distributed ledger where all data is stored. Whatever the happen in the those blockchain network, those they gonna be saved on this whole information or whole data in that systems things. And it is not only one system that is stored with the multiple system or who is involved that network, everyone has a stored that same system. So currently just for a little bit just forget about to the vehicles, we talking about to now blockchain concepts things. So blockchain this is currently just based on the only talking about to the system storage with the any one network things. And that is the digital distributed ledger is ledger word is comes from the finance world, where is a finance are they are storing the your all transaction. When you open any bank account in the bank, they are started to whatever transaction you are going to done with that bank, they have stored and all information for you. So that is the centralized bank concept is a centralized, but those concepts similar as it's talking about to in the some wide range, some big places means anyone in our network has like involved in the 10 peoples or 100 people or 1,000 people, everyone has stored the same information about to each others that things. Second, the type of distributed ledger design to record the digital interactions of the for the purpose of transparency, efficiency, and added the security things. The second, we talk about the consensus as a replicated, shared, and synchronized digital data geographically spread across multiple sites. There is no central administrator or centralized data storage. And there is a second thing they're talking about to consensus. The consensus is talking about to the some mutual understanding between the network, between the nodes, or between the nodes of the network. How many nodes in the network they have a mutual understanding what are the information is transmitting in the network, one node to another node. The others member of the nodes, they have to agree that okay, these are the going on, that these are they can be do that based on the legalities. So yeah, they are approved to based on their based on this distributed ledger and their background, what transmission they did previously. So based on those things, so those all things we are just going to be connect with the block our vehicles one. So I'm just giving the just overview about this. Second, we have third, we have to cryptography. Cryptography is talking about to the each network has their same and follow sorry cryptography they have creating the using for the privacy purpose. Who is involved in the node, they cannot identify to others the personal information or personal things. They just have some hash id, those 256 sha secure hash id they created, and based on those hash id they have did the transmission, did the transactions in the network. So nobody knows that who is sending that informations. They're just finding the only hash id and those things. So that is they're talking about to the cryptography, and that transaction is also been involved. Behind that there is some mathematical problem is comes, though who solve that mathematical problems that using for that structure, that is called the minor things. Third, we have the smart contract. Smart contract is simple way, like before joining the network you there is some rule and regulations they have. Like for example, we are going to shopping for mall. So if we go to buy something, they have given the price tag in the mall. So we cannot bargain that and we cannot see it. We just bring those things, give the money and come back, right? So that's the way. If that the same things for the some network, before joining in network they have already displayed their rules and regulations. If you are agree that things, then you can join in the network. If you don't agree, then you don't need to join those things. So that's the basic smart contract concepts. So let's see why blockchain and intelligent vehicles are common. So here we're talking about to block automotive field. They need they have to safety cultures, and the information technology industry they have security culture. So somewhere this blockchain is providing to this, making the safety and security culture together in the automotive fields. That's the way. So the pinnacle, the accomplishment of the merging of two industries, like in the automotive industry and information technology industry, is the development of the self autonomous or self more advanced vehicles. Safe, more advanced vehicles that utilize the security characteristics offered by the blockchain network, blockchain technologies, things. So that is the why blockchain is intelligent vehicle. Blockchain and intelligent vehicles can be combined. So there is like several features we already talk about to the current scenario in the self-driving cars or in autonomous or intelligent vehicles or automotive industry. Several challenges we have. So those challenges can be we can try to solve with the help of only one blockchain network, using the blockchain network. So for example, these are the traditional challenges, traditional security protections they have, like centralized architecture, ITS, that is all governed by the government. They can see what is the traffic things and what not traffic, even though like every whatever you are communication for the service purpose, for the any inside of the vehicle communication, whatever using is all is a centralized power using by centralized architecture. There's a heavy on the resources, they require to heavy resources. So unable to protect data that is mobile, because vehicles is the moving one location to another location. So they are in the moving stage, they are not able to be protect their information, their data. They're not focused about that much data security point of view, about data security point of view. So unable to handle the large amounts of data at some places has a increasing lot of data, generating lot of vehicles are intelligent in the advanced vehicles is coming, self-driving car and autonomous vehicles coming in, more intelligent vehicles coming, they are broadcasting lot of data, changing in talking some services information, some locations, something. So any type of things they have talking to vehicles talking each other. So they have multiple vehicles, the lot of congestion, and due to that there is a, and in a one place there is a more than 100 vehicles, and every vehicles are generating the information. So they had not current time is not possible to handle those data, how to possible the manage those data in the same time. So no access to the vehicle history. There is a like once vehicle has did some accident and those things, so those information when he gonna be resell those information not easily get it, that anyone can be just modified their vehicles to different color and different things, and they can ask that okay this vehicle is the new vehicles, and he can resell those vehicles. So they have no access the vehicles history, no distributed network things. So these are things possible if you go to very more detail and one by one to be checking those things. But those things are little challenges for the traditional intelligence, traditional security protection for the automotive field. So this blockchain technology has providing to the decentralized architecture, the low on the resource, and able to protect the data that is mobile, able to handle large amount of data at the same time, and access to the vehicle history, and also is providing to distributed network things. So let's see as I talk about to the these four things again comes here, like how the consensus, distributed ledger, cryptography, and smart contract gonna be change the relevant blockchain characteristics for the intelligent vehicles. How do they gonna be provide those things? For like consensus where all parties agree to the network verified transactions, even all parties not agree but still more must be there is 51% of the network member are agreeing on the some any transaction or any transmission as going in the network, they must be agree. So they providing to consensus, providing to the trustability, liability, and authentication in the network, in the whole within the this blockchain network, a vehicle communications network. Distributed ledger, they had append only system of records shared across the business network. So it will be providing to availability, retainability, and traceability. Third, cryptography, they are ensuring secure, authenticated, and verifiable transactions to, to give us to protect a confidentiality, making the privacy, data encryptions, integrity with the data message or data integrity, that is data is not modified in the network, those things. And last, smart contract is making the terms embedded in the transaction database and executed with the transactions. So the trust negotiation process and final contract that is providing to trustability and reputations in the network. So these four things, how can be they are providing in the network to more protected or more connected with the this intelligent vehicles environment things. Let's see, this is the vehicular cloud. They have connected with the vehicles to everything, providing to this blockchain network, blockchain servers there, and this blockchain server has to be used to be connected and making the more protective. So this means they have connected with the node as a node of the blockchain servers things. So this one idea we had as taken to present when we have started this idea, we had presented in the MIT, USA, MIT. We went for the conference there, and I delivered that our ideas from there, and they are like these ideas and new things from that time for this using to blockchain in different places. Things in this conference in MIT. Second, we have to push the blockchain. This blockchain technology can be pushed the some solutions utilizing the same basic road and highway infrastructure. There is increase the number of passengers, increase the amount of goods, increase the average speed, it will decrease the congestions, decrease the accident and crashes, and decrease the carbon footprint. So these are the some benefits when we using to the blockchain technologies and solutions as a as a automotive field or intelligent vehicles field things. So this is how to this process gonna be done with the vehicles, intelligent vehicles. So using that is the like vehicles. He is the part of the intelligent blockchain network. He's enabled the autonomous vehicles. He just sent the some messages with the block, and it can be crypto hashing and transmission of the distribution and validation validated. And these are the some nodes in the blockchain servers. They have verified things. Data transmission is committed to the blockchain, and miners rewarded, and receiver the blockchain enable autonomous vehicle, they receive those things. So the vehicular cloud is a hybrid technology that uses vehicle resources such as the computing, data storage, and internet decision making. It is the using the miner word here. Miners are blockchain enabled vehicles that can be validate the data transmission in the network. So these are the things. So these are the our process of blockchain technology in intelligent vehicles. So that is the process, like one senders are sending and receivers receiving. So they have messages going on to those each others. So here we talk about to the some miners, right? So why there is minus gonna be work? We cannot give them to the cryptocurrency because it take us so much complex this thing. So for that reason, we have proposed our new crypto points. You can say that our reward, we have created our own reward that is called the intelligent vehicle trust point. So they using the trust point. So that trust point has to use for the multiple purpose. One, to they can be used trust point to vehicles validity or vehicles trustness, how much vehicle are joining the network and communicating, uh, involving in the transmission and verifying something or as a work as a miner and those things. So this trust point have using to purpose of the vehicle's trustability can be checked with the this trust point. So once the vehicle is gonna be resell after some time, so he just shared his intelligent trust point, vehicle's trust point, and based on those trust point, he can be negotiate their price of the second-hand vehicles. One thing, another thing, this is a trust point is another useful thing. Current time we are paying for the whole insurance of our vehicles during the insurance year. So for this insurance, currently we can, if we be using the only trust point, can we show to the insurance company and we can bargain for the okay the our trust point, our vehicle's trust point is very high. So we have to be how much insurance we can be pay insurance fee we can be pay, and according to trust point we can show them their data, our data through the blockchain network to display that how much we how safely we run, how we, trustworthy we information we have broadcasting involving in the transmission. Those things can be used for that another insurance purpose. Third, it is possible the trust point can be helped to be in the binding to the insurance, and trust point is a help for the services. We get it the some services for petrol pump and those things. So those services we can use this trust point to the on the service purpose. We can connect those things. So that three purpose we had planned to be connect. That's why we have introduced our intelligent vehicle trust point in the vehicle communication things. So that so they trust point get it from the some authorized organization or intelligent vehicles. For the trust point there is center are issues unique with the crypto id, and those vehicles can be involved getting the some alphanumeric ids, the crypto ids things. So that vehicle id we can use into those transaction connected with the this vehicle id, and those are they can be first time they can be get it, after that they're gonna be generate themselves to be receiving and doing the involving in the communication in the network, those things. So why these reward points we require is important to our network? Why we require this intelligent vehicles trust point? The simple logic is like if anyone is involved going to do something from in the network or from the personal way, they must be expect something back. So that's why we have introduces this. Someone is going to do the some mining things or some minor mining work in the network. They must to get it the some reward as a reward based this trust point things. So blockchain is a secured, trusted communication based on the blockchain server. Store the vehicle has ID, IVTP, and communication details. Things like this, so they can share each other's the whole network. The blockchain servers, blockchain enable autonomous vehicle or not intelligent vehicles to be getting the more advanced vehicles can be who can be easily communicate. They have communications vehicles inside of, so they can be used those blockchain IVTP can be used it. Now comes now is there is question is they can't possible to be a how blockchain gonna be use it, right? How to if there is some conjunctions like in the some intersection has the so many vehicles are coming to several way. So how can we manage those things? How to the every vehicles are generating those data? How those data gonna be managed? So for this purpose, we have proposed this LDB and MB, two network, two layer of the blockchain network. Two layer blockchain network means first LDB, second MDB. MB, yeah, MDB or MB, anything, both are same. So LDB is the local dynamic blockchain. MB is the main blockchain. Local dynamic blockchain means that, for example, this intersection vehicles, several vehicles are coming, they are coming and they their information has stored in the blockchain network in the local blockchain servers. And if there has something happened some is because normally the vehicles are talking is simple things, where is the petrol pump services related questions, some other related traffic questions, those type of some communication is going on, they're generating according to that data. This way they want to give, they want to go. So that type of some common general question is going to talking about to every vehicles. So our blockchain LDB blockchain they have just over storing those information is the overriding, there is the not very important or we can that not effective informations to be effect to the network. So they are just using those in the local dynamic one. If something happens, some big thing like accidents happen, a car has crashed and something happened, so those are some traffic jam and those time something happened, those information has stored in the main blockchain that goes through the via local blockchain things, local dynamic blockchain one. So why we using the dynamic one? Dynamic blockchain we have using to be because the dynamic blockchain we had providing to the limited memory, limited storage capacity. So after the capacity full, then they're gonna be override those informations things. So that's the way we have proposed to this LDB and MB blockchain. LDB they have overriding the informations going on, and main blockchain they have storing the summary event based, any something happened, some event has happened, some problem has happened, those information has summarizing and they're going to store in the system in the main blockchain. And that main blockchain they're going to be stored the permanently, not for the few times. So for this is a, for example, this is the current scenario of without blockchain we have trusting only completely on the traffic signals, red green yellow blue, red green yellow, red green yellow. So though based on those things, we have following those only those systems. We are following the network. So if blockchain is comes, then we have to this type of seamlessly this type of communications. Like vehicle is coming, these are the blockchain servers. They have connected those things. They are just sending some informations to sharing the information with the hash ID and IVTP. They are communicating with the help of this blockchain network things. So this is this animated blockchain intersections. There are no traffic signal of any kind. Each vehicle has unique ID and all its information, speed, direction, location, and capacity and capability. That is the incorporated. with the blockchain technology within the vehicles. So when entering the intersection, the unique ID for every vehicle is uploaded, their information uploaded in the blockchain servers, and hence the intersection becomes aware of every oncoming vehicles in the relations to the other vehicles already at the intersection. So the data received by the each vehicle is will be determined whether slow down or speed, control the speed, or which section, which side we gonna be work, like those type of which side uh, speed up, so to cross the maximum speed and all safety things. So the related that things, it can be vehicles automatically going to be manage those things. So this is our blockchain block network or block structure of this, where they are using to the hash function, previous has block, and that is timestamp version, what the version of block they are created, and messages, what the message are, what type of messages broadcasting in that locations. So they are using this structures. So we have for the creating for the one block things. Next we have to use like here, that is the previous block hashes. The previous block hashes can be more than one if blockchain is the branched, or all of them are appended. Second, we using the timestamp, the time when the state was generated, message information that vehicles want to be transmit to the another vehicles, and version of block, whether a block was attempted more than one time or not. And this is the whole hashing function. Hashing is the transformation of a string of character into the fixed length value or key that represent the original strings things. So that is the whole block structure. How can we, they're gonna be created that blocks in the our communications in the blockchain servers. So understanding the state change of vehicles, of intelligent vehicles. State change means like when they are coming on the intersections, like here, to when they get the receive the information from blockchain, then they need to control their speed, stop, speed control, or acceleration, going fast. Those are the talking about to the state change. That is the state change of the vehicles. In this manner we are talking about a state word. So the state change changes of vehicle contain the information about updates in the vehicle's position, like velocity, acceleration, speed up, speed down, so on. So state change contains the following four fields, like this: a unique ID, which is randomly generated in order to avoid minings of the similar blocks. That is the timestamp denotes the time when the state was generated. Message broadcast, the position contains the location of the vehicles, including the directions in the which the vehicle is moving. And this is the fourth one, is that the state change type records various item, including information on start, acceleration, braking, turning, halting, reaching a point, and magnitude of the actions, like that. They're talking about things. So these four values are included within the hash block, which must start with the specified nonce or number of zero. So now we have to, that is the our we introduced to our blockchain network into the system. But how can we manage, like if there is a too much congestion, data, too much informations are coming. So this is the our overall introductions about to how to blockchain in build in intelligent vehicles. And this is the in this intersection example we had this did the simulation for this sections. I will show in the next coming slides how to do the did that simulation work. But you see, after that, introducing this blockchain, journal blockchain technology, we have some challenges, found out some challenges. Like consumption of significant amounts of power, requires large size data server to manage the information in real time. Storage of data needs to be stored for long period of time, that more than 2 years. And management of data exchange in mobile and dynamic environment is difficult to the manage same time. So for that purpose, we had proposed the branching, branch-based uh, branch-based mechanism for here, like local blockchain and main blockchain technology. We have using to the branching system. Then this branching system with this local dynamic blockchain, when it getting the more congestion, same time you getting the lot of information. So what the local dynamic blockchain, they divided to the getting the informations in the branch wise, different to more than two branch. We have talking about, we in the here we had divide in the three branches, and later on when congestion is reduced, the branch is gonna be automatically covered, automatically combined together things. So this overcome up to this blockchain, the two part blockchain mechanism solution proposed, like part one, dynamic blockchain, other is main blockchain. We already talked about that things. So LDB, like local dynamic blockchain, is stored data according to its size. Once it's full, old data is overriding things. And with the new data, according to the first in first out FIFO principles. So if LDB receives any unusual data, not regular data, it forward to unusual data to the main blockchain. Unusual data, I already talked about in the previous slides, to be some accidents happen, some emergencies vehicles coming. So those type of some unusual data, when he's received, those information is forwarded to the main blockchain, where main blockchain they are going to store through long period of time. So in our simulation work, we have considered the our these things about to the 6 month period durations. So the storage time can be increased, decreased according to users or administrators, ITS administrators decisions. So LDB store the data in list form. Each list has the dictionary and branching factor value. So the branching factor denotes how many branches we have. We have to create it in the LDB, has the bottom most level. So the number of branches can be calculated as a 2 to the power branching. So LDB is implemented in circular queue, as in we previous slide when introducing the blockchain one, this way. So this is circulating purpose. We are using the LDB in the circulated or overriding point of view, overriding the data, and is going on the circular form. Yeah, so their circular form LDB is implemented in the circular queue for limiting its size. Hence, the maximum limit level is may contain the specified. So, how do we go do this branching process? So, branching is performed by local dynamic blockchain when amount of traffic can be handled in the real time. So, the branching process is governed by these equations like delta T, like these equations. Delta T is average time, which equals to the summation of difference between the mining time and message broadcasting time over the total number of vehicles is there in that particular locations things. So this is the number of n is the number of vehicles, I is the vehicles ID, and time block mined minus 10 to the power I broadcast, the which number of the branches we're going to be used, and divided by the total number of vehicles we have that locations. So it is like this is the single branching, talking about the single branch. If there is a low traffic, then divided in that only two branches things. But if there is a high traffic, then we have created a multi-branched LDB. So there is a block, we created an annealing block, and that block is again divided in the blocks. So block branches cannot be merged things. So if LDB has branches, a block has the possibility to be added in the blockchain, hence making the process run faster. So multi-branch, when LDB recognize that traffic has decreased and can be handled by the lesser number of branches, it can be merged two branches. So here we talk about block branches cannot be merged. So once that means when block has a lot of data is coming, so if already created their own block, so that block is not going to be merged with the oldest previous blocks that created the another branch based block things. And if there is a traffic is reduced, there is a no coming only can be handled by the one signal, then it that this block has the empty, and after that is this block going to be merged within the single branch things. So a branch in LDB can only be divided into two child branch or and not more. So the this blockchain is used to keep track intelligent vehicle trust point transaction between two vehicles. This operates in the way similar to the Bitcoin mechanism. Both Bitcoin mechanism, they process the Bitcoin mechanism, but is not using the any Bitcoin concepts from here. So both in the Bitcoin universe and the vehicular blockchain environment, we utilize the Merkle tree to creating to the blocks we using to Merkle tree. So for example, like construction of branching process, there is a main branch implemented using the Merkle tree, like previous branching factor greater than current branching factor, then previous branching factor less than current branching factor. Then they calculate after that is the branching factor of parent. Current branching factor is trivial case, one parent has one child. And this is the about to the Merkle tree that only contains the hash. It does not contain the transaction data itself. So content the transaction data is like transaction zero for they started like these are the multiple transactions 0, 1, 2, 3. So they have connected they have combined two transactions creating one hash, then again one hash. So with the help of that the way they have creating to the blocks transactions, they combining to they going to the uh, bottom to top and making the one block has the multiple transaction. One block can store the multiple transactions. So the transaction has in the Merkle tree, and after purning the transaction 0 to 2 from the blocks, they have created this type of block creation is done by this way. So this is our flowchart or pseudocode, not flowchart, pseudocode about to the miner. That we using the function miner thread that is they start like the miner thread functions runs from the starting of vehicle to its shutdown, taking care of the mining procedure. Template get the template that miner thread along with the mine block carry out the solutions of the hash function, thereby generating the proof of work things. Mine block that is using to is equal to mine block to mine and template, where the get template function queries the local dynamic blockchain for the template. A list contain the information such as a version of the blockchain and parent hashes, so on things. And this last we have using the if add the block, the add block function simply send the mine block to be added in the LDB subject to verify the proof of work, that is called the consensus mechanism things. So that's the use case of our blockchain based intelligent interactions. So here we are looking at the blockchain based intelligent intersection as shown, like we have four vehicles I1, I2, I3, I4. So when the vehicles are about to reach the intersection, they broadcasted their signals. A consensus is reached regarding vehicles has the earliest timestamp associated with the block and which cross the first. So the vehicle which calculate the proof of work the fastest earn the IVTP, and vehicle is allowed to move. After that, the same procedure is followed by the other three vehicles too together. So this is the based on the message broadcasting. That is the started message broadcasting first IV2. IV2 there is a 10:02 AM they have starting. So based on the message broadcast time in the network, each of the vehicles is depicted, and from that way intersection of the vehicle I1, IV1, IV2, IV3 and 4 reach the intersection at the different time. So at the processing time we have using to started from the 000, and all the vehicles have same IVTP value which is set to the 10, and intersection are the vehicles are coming to the like first IV1 is coming 10.6, IV2 10.2, IV3 10.4, and IV4 10.3. So this now in this table has shown that the processing table that is calculated, the for each step defined can be seen here in the remark. For example, this one that is the talking about the arrival time. This one is talking about to the processing time, how to they like started from this, and they each vehicle has starting the processing time for the calculating the which vehicle going to move first, that blockchain mining things or process things. Then these are the vehicles informations. So the remark, there is no vehicle issued start the block if IV2 sends the start blocks start moving, IV3 IV4 first in the start the issuing time is 000, and then it will take 5 seconds, 6 seconds, 7, 10, 2, 12, 15, 20, 28. So that way they have creating to the whole vehicle, and these are the IVTP values of the each vehicles. They starting has a 10 values, and later on which one has a defined, they are delivered those to that I, for example, IVV4 has created the did the mining, so every vehicle has giving to appreciation IVTP to them. That's the way they are using things. So for example, they have no vehicles at the processing time is 00. All IVs have the same IVTP value, and then we can see this is the coming first, this is the second, third, and fourth, and this is the did the reward points. You can see IV4 get the reward points from the others, everyone's. So that's the way we have calculating to the reward calculations for the making the blockchain process based on the rewarding, and like similar as the rewarding as happened with the similar as the blockchain as a Bitcoin process things. So this is our difficulties level, like for the computation with the computational power regarding to the vehicles they require if we using to the 50. So there is a problem has taken around to 62 minutes, around 1 hour to be giving to the this making to that table, or making to the who making to the mining, making to approving the those mining process. So it will take the one more than 1 hour for to this process. So what we did that we had reduced to the this level of difficulty in the 0 to 3 level. From here there is a 1 second, and this we did the average of after 100 of tries. So our difficulty level, there's number of zeros in begin of the hash, and average time is taken for the mining. So in that case we have find out the level 3, it will taking the almost 1 second per tries for the creating the calculations of things. So our for our simulation purpose we have using these sections, level 3 problem of difficulties we did. So this is our simulation analysis for applied blockchain technology solutions. For example, like blockchain, Windows 10, that is the blockchain servers. We are using that as a vehicles with the, these are computers as the vehicles. And we find out the calculations, did things with the average time taken by the mining analysis in the seconds divided by the number of nonce. So these are the like number these zeros are the nonce values. So we're talking about using the 3 nonce values things. So these are the level of conjunctions we have using the single branch and multi branch, both we tested those things. So for example, that is our simulation results. So in here we can see that vehicle has the coming both way, everyone has a 10 IVTP, and then they are moving, creating the mining is done. So this vehicle is giving to the value to the this vehicle, and this vehicle is getting the and this one. So they are sharing to each others. So their IVTP giving them to that things. So let's see more explanation about this our use case scenario about to how do we did that things as a talk. The we using this intersection use case scenario. We test use phase 1, phase 2. and we using the level 3, those things. So here we have it's receive use case test phase 3, receive the rewards, provide the IVTP, and create the table of vehicles with the based on the timestamp which vehicle comes in here first, and then according to that table the vehicles are moving or crossing the intersection things. They have generate the table and generate the table generates the table. This also generate the table. They also store the all information about their generating the table. So this is the showing to about to branching. When we did the branches, then how much time it will taking for the branches one. So the average time for a state change validation with the load of 2200 state change per minute for the one branch. Second, this pink purple one is a one branch. Green we're talking about two branch, and four is branches, four branches things. So that is the value. So in order to the, we can say that the branches had the average time of state change of 2200 state change had uses, and in our next experiment we have using for the 2400 changes. So that is showing our average time for the state change validation with the load of 2400 state change. They give that the 14 second for the unbranched, no branches, only one is there, unbranched LDB. 6.5 seconds take for the LDB with the one branch, and 5.5 seconds this will take for the LDB with the four branches of that thing. That's value. So here we can see that our branches is divided. If we when using our branches wise methods, then it will give the more fast result to that. Third, we have to the another tested for the 3200 state change per minute. So there is a using for the 1600 seconds for the LDB for one branch, and 14 seconds for the LDB with the four branches things. So that is the our results. And now we're going to talk about I'm going to conclude and going to discuss with your question answers. So this is able to handle the large amount of data at the same time. This blockchain can be accessed with the help of blockchain network. We can access the whole history of the vehicles, where what type of transmission is done and what type of communication is involved, and is giving that seamlessly transmission or transportations network, where the vehicle is going to be seamlessly move one place to another place without to stopping green and red signals things. And decentralized, distributed, secure, trusted peer-to-peer network. And it's giving the future work we have is still like blockchain to use in emergency vehicle scenario. How to going to use blockchain computation is still high. We need to reduce to more for that. Consensus protocols we have in here. We have using some new consensus, our own proposed the proof of driving consensus, but we still be required to the change those more new consensus program algorithm we require, and still a lot of research scope is there available. These are my papers or references related with the only this blockchain technology for intelligent vehicles that I used to my presentations for these things. So it's all is my paper, and there is a we have also proposed our one of the patent that we used for this structure, our branching structure that already got the patent for that structures things. And these are my books. I have already done this much book. This is our IEEE, this all automotive cybersecurity IEEE lectures we have already running on this, available in the internet or in the IEEE. If anyone interested, then university can be provide those lectures to them, to students. They will be getting the more idea about to how automotive cybersecurity works. Not only blockchain, it is the more basic concept requirement, and managing to those more deep learning based approach about to automotive cybersecurities. So all those things is providing. So okay, so I'm not running this video, just going on to next. Okay. Oh, so these are the another editor of the this sorry, this book series, blockchain technology book series I'm running already, editor-in-chief of that. So for the some professors, students are interested to writing some paper and chapter or book itself, they can contact me. And these are some journals where I'm editor, associate editor, and editors of that journals. And this is about me. And that's already Saloni has already explained. So yeah, thank you very much. Now if anyone has any questions, then let's discuss about the questions.
Thank you, sir. I had few questions, but every time I had a question, next slide you explained the reasons for it.
Yeah.
Once I wrote the question, and the next slide you were explaining the reasons. I was like,
Okay, so you already got the answers.
yeah.
Okay.
Just the one thing about the emergency vehicles.
Sorry.
About the emergency vehicles like ambulance and
Yeah.
all. Is there a priority scheme for that?
Yeah, for that I have already proposed another things to be only blockchain. Like I proposed local dynamic and main dynamic one. So there I have also introduced one more blockchain servers that is the based on only emergency informations. They can be that making the some branch that can be connected always with the emergency servers. If there is something happened, like some information received by the main server, okay, this information like regarding the some unusual information, right? Some accidents happen, those is received by the by local dynamic to the main branch, and that is immediately broadcast sent to the emergency servers. So their vehicle already on the, they get the location and all information, they move on immediately for that particular locations things. So we have already that work also, but not still we have in the simulation way, not done completely, but we have proposed. And like in the, if you go to I had just finished my this book has completely involved like intelligent. Last year I had just published intelligent information security for intelligent vehicles communication book. So this book has all getting the this emergency chapter also we have included in this book. That things. Yeah. Yes. Any other?
Sir, I have a question.
Yes.
Sir, as sir, जैसा कि आपने बताया. Yes, sir. In this,
It's
there
okay.
was
We
this
can.
thing.
It's okay. We can talk in Hindi also. हिंदी में
Okay,
बात कर
sir.
सकते हैं. No problem.
Yes, sir. Sorry, sir.
कोई
I
बात
was
नहीं.
just. सर, इसमें आपने जैसे बताया कि हम मतलब कुछ इंटरनेट से कनेक्ट करके वो हैश आईडी अपलोड होगी वहाँ पे जो ट्रैफिक सिग्नल पे सर्वर होगा हमारा एक वहाँ पर. तो सर मतलब ये क्राउडेड एरियाज में कुछ मतलब वो नहीं होगा. जैसे सर हमारे पास अगर एक जगह पर 2.4 गीगाहर्ट्ज़ के बहुत सारे नेटवर्क हो जाते हैं तो सर अपने आप ही वो नेटवर्क की स्पीड रिड्यूस हो जाती है. जैसे कि सर मैं अभी कल फेस्ट में गया था तो सर वहाँ पे 2.4 गीगाहर्ट्ज़ पे बहुत सारे मोबाइल फोन्स ऑपरेट कर रहे थे. तो सर मतलब सिग्नल आ रहा था लेकिन कॉल नहीं लग रहा था, ना डेटा ट्रांसफ़र हो पा रहा था. तो सर ऐसा कुछ दिक्कत आ सकती है?
ऐसे दिक्कत के लिए भी हमने वो किया है कि इसको हम जैसे 5G, अब तो 5G आ गया है, राइट? तो नेटवर्क 5G के साथ भी कनेक्ट हो सकता है और सैटेलाइट नेटवर्क के थ्रू भी कनेक्ट हो सकता है, क्योंकि जो कार्स होती हैं उसमें ऑलरेडी वो सैटेलाइट नेटवर्क के थ्रू चलती हैं, राइट? उसमें जो म्यूजिक आते हैं, जो रेडियोज कौन सा चलता है, FM, और जो वो चलते हैं रेडियो मिर्ची, इस तरह के जो चलते हैं वो सब तो सैटेलाइट के थ्रू होते हैं ना. उनको कनेक्शंस और इंफ्रास्ट्रक्चर जो ITS इंटेलिजेंट ट्रांसपोर्टेशन का जो सिस्टम होता है, जो कि गवर्नमेंट की तरफ से रोड से भी प्रोवाइड किए जाते हैं, वो सारी चीजें के लिए तो दूसरी चीजें चलती है. तो व्हीकल्स में हमारे पास मल्टीपल कनेक्टिविटी के लिए ऑप्शंस रहते हैं. चाहे तो हम उसको मोबाइल से कनेक्ट कर लें, चाहे तो सैटेलाइट से कनेक्ट हो सकता है इमीडिएटली, चाहे तो वो तुरंत ओवर वो कर जाएगा. अगर किसी नेटवर्क का अगर कोई इशू प्रॉब्लम हो रही है, कुछ कंजेशन हो रहा है कि नहीं हो पा रहा है, तो डिफरेंट हमारे पास चैनल्स होते हैं. तो जो ये इंटेलिजेंट व्हीकल्स में होता है, ये स्पेशली दो तरीके के यूज करते हैं, DSRC एंड वेव. DSRC होता है डेडिकेटेड शॉर्ट रेंज कम्युनिकेशन, सो जो कि शॉर्ट रेंज के लिए होता है, विद इन किलोमीटर्स, और इनके लिए होता है. और वेव का यूज करते हैं वायरलेस एक्सेस व्हीकुलर एनवायरनमेंट. वो नेटवर्क होता है, वो बहुत ब्राइट वेव के लिए कनेक्टिविटी होती है, तो उसका अलग स्ट्रक्चर कनेक्शन चलता है, राइट? सो उस हिसाब से व्हीकल्स अपने आप को मैनेज कर सकता है. अब ये या कह दो कि न सारे व्हीकल्स एक ही जगह खड़े होके वही एक्सेस करेंगे, व्हीकल्स तो मूव करते रहते हैं, तो वो तो कनेक्शंस अपने आप मूविंग, इधर से एक जगह से दूसरी जगह गया व्हीकल तो अपने आप वो प्लेस फ्री हो गया, तो दूसरा व्हीकल वहां पे आया तो उसने एक्सेस कर लिया। बट अगर आप ये कहो कि सारे व्हीकल्स एक ही जगह खड़े होकर सारे एक्सेस कर रहे हैं, तब तो ऑफकोर्स कम्युनिकेशन प्रॉब्लम हो सकती है। लेकिन व्हीकल्स में ये फैसिलिटी है कि उनमें मोबिलिटी होती है, वो मूव करते रहते हैं, राइट, तभी उनको कम्युनिकेशंस की जरूरत पड़ती है। तभी ये इसको, जैसे मैंने अभी इंटरसेक्शन वाला एग्जांपल दिया है, इंटरसेक्शन में बहुत सारे, अभी क्या होता है कि हमने ट्रैफिक सिग्नल है, सारे सारे लोग रेड सिग्नल पे खड़े हो गए, अब सारे लोग खड़े हो गए, वहां पे काफी कंजेशन बढ़ गया है, तो उसको उस टाइम पे कंजेशन प्रॉब्लम हो सकती है। लेकिन अगर हम उसको रिप्लेस कर रहे हैं ब्लॉकचेन के थ्रू, सारे व्हीकल्स वहां आने से पहले ही इंफॉर्मेशन दे रहे हैं कि हम आ रहे हैं और हम इस लोकेशन की तरफ मूव कर रहे हैं, तो ऑलरेडी सारे सारे व्हीकल एक ही लोकेशन पे तो जाएंगे नहीं, वो ऑलरेडी अपने आप वो हो जाएंगे, डिस्ट्रैक्ट हो जाएंगे, और उनका इंफॉर्मेशन, उनका कम्युनिकेशन चैनल भी डिवाइडेड हो जाएगा। तो उस वे में दे कैन बी इम्प्रूव देयर कम्युनिकेशन पावर। बट हाँ, सम अगर कुछ अनयूजुअल केसेस हुए तब तो कुछ प्रॉब्लम तो हो सकती हैं उसकी, फिर एक्सेप्शनल तो हर जगह होता है, राइट, इन टेक्नोलॉजी में भी एक्सेप्शनल तो पॉसिबल है।
Yes, sir.
Sir, there is a question from one of
Yes.
our participants. That is, how can blockchain be integrated with machine learning?
How can blockchain will integrated with the machine learning? इसके लिए ये है
Yeah.
कि कहाँ गया, सॉरी जस्ट अ सेकेंड। Yes. So machine learning, we can use it as a cybersecurity point of view. We can define the what type of threats can be happen in the some particular way, particular network. So those network we can store in the blockchain can be help as that. Machine learning is also using for the data analysis, right? For the trained data. So we can store those trained data on the blockchain server. So those machines, similar type of features are using the machine learning can be easily accessed by the other locations also. So that can be talking about the data access, right? So data access can be possible with this machine learning data training. Using for the data training purpose, we can be use this blockchain network. Is it possible? And
Okay,
like
sir.
nowadays, is as a security point of view, lot of people are using to machine learning, artificial intelligence for the security perspective. We already defined that all threats, and those threats can be overcome automatically when it comes to happen in the system. So those type of data we can already provide to the system in the blockchain server, and that data, like unknown people can be provide their feedback, right? So though unknown people can be also, like I'm doing some research on this my particular security issues, those data I already uploaded on those blockchain network. Someone is from India, someone is from USA, so if that blockchain network can be easily collected those data and can be easily shared with those information and those type of data, they are providing to train data, so directly we use those train data and start our implementations things. So one point security point of view, one protection point of view, so that type of things can be we use for the blockchain network in machine learning things. You got it
Okay,
answer
sir.
or still?
Sir, I'm just asking the questions from the participant that they have asked it during the registration part. And then next question is that can intelligent vehicle be helpful for decrease in accident count during foggy weathers and many other adverse conditions?
Who's this is Webo?
Yes, I'm Vaibhav.
Yeah, Webo. Actually, your voice is little not clear. Can you?
Okay, let me
Can
say
you
it once again.
can you give that in the chat box? Can I see that questions?
Okay, just wait.
Yeah, one question
I will
is
just type it out.
sorry, one question is regarding to the intelligent vehicles. Can be?
I'm just typing.
Okay.
Sir, there is one more question that I want to ask.
Yes.
Sir, as discussed in the example above, that intersection part example, the what kind of security is provided to that servers on which the vehicle data is uploaded?
Which data is uploaded? That is using already blockchain, right? The blockchain has the storing the data in the hash form, right?
Yes, sir.
So that's is already when you need to access the data, you need to crack the hash functions. So that is the as we using to very long hash function. So it's not possible to be cracked to creating the blocks one.
Okay.
For example, in the Bitcoin, what they are using, they're using to 256 multiplied by 256 to the power 19 something. So
Yes,
that
sir.
much long hash function they are using. So, but we cannot use for the vehicles that have long hash functions, right? So for that purpose, we have using only 256 can be created for the one vehicles hash ID. So if and when it information is the in the plain text, but when it going to inside of the block, there is a several we talking about the Merkle tree, right? Merkle tree talking about to the transactions, but those Merkle tree is going to be like there is a 10 Merkle tree, 10 transactions. So then they combine 2 to 2, there is a 5 hash function, then again combined 2 to 2, they have 3 hash function, then again combined 2, there is a 2 hash function, and then all combined the uh, functions together. They have okay, in here you can see where is that Merkle tree one. Okay, this, can you see my PPT, right?
Yes, sir.
So this is the hash we talking about to the hash functions, right? This is the transaction, this is the plain text we're talking about to the vehicles, but when we are creating in the block, they have change in the hash functions, one one separate, then again they combining those hash function in the one hash ID, then again combine that same process done by this side. Now later on they combine only this two hash ID. So you can see how much layer to reaching this information, this transaction information, they need to crack the from this block to the here, that much hash function. So that is the taking a lot of time and taking too much time and power. So they cannot it's not easy, and I'm not saying that it's not possible, but it is possible. But it's come when it's coming to like quantum computing and that type of advanced, more advanced computational power is to us, then it is a hard, then we need to think about to how to make this secure more. But still till now that is the more giving that more security, because of they have multiple layer of the hashing power, hashing ID. So has, and when they created the block, you can see there is one two three three hash ID in the layer. This is the one example, but that can be possible as a one time in the blockchain. They mentioned like every 10 minutes how much transaction is done, they have combined and creating the one block. That combined means they have combined like this way, every 10 minutes what the how many transaction is done, they're combining in the changing in the hash id hash id hash id, and then make create the whole block. So it is not easy, and it is hard to be cracked. And another things like vehicles are moving, right? So once they are getting the information, they already move out. So when it going to another place, if they have cracked, they get it the information about that vehicle. So they, that's I'm saying that in the local dynamic has not the problem, they have already overriding the servers. But main problem when is some accidents happen is stored in the main blockchain, they have already stored in the very huge protective form. So it's not easy to breakable to be changed the to see the what the information is there is mentioned. Okay.
Yes, sir.
Yeah. So now web, can intelligent vehicles help to decrease the accident during foggy weather conditions and other adverse? Yeah, that is the automotive, that's why it's coming to more advanced automotive technology, right? Automotive technology they're providing to different fog and different like some congestion is there, some information there, you get it the automatically information to that location has some accident, you can change your path. So that type of information you have receiving current time for that type of vehicles is already giving fogging. So there's a different lights coming, and different type of lights are coming, and they can be attached those things. So that is the more mechanical point of view. You're talking about that intelligent vehicle, there is a intelligence things is to they can use the sensors for the object detection. Here comes to for if we talking about to very smart intelligent vehicles, so that very smart intelligent vehicle they can sense to object if something object detection form. if something happens, something new in front of vehicles, that they can be detect that okay, there is some object, they can be stopped. So that type of if mechanism comes for that intelligent vehicles object detections things, then is easily there can be of course they can be possible to decrease the accident and make more protections. Any one more questions to Weber? You said that is the one question. You got the answer, right?
Yes, sir. We got answer.
So any other questions for you said that there is a two questions, right?
I was the previous one, the machine learning one.
Okay. Yeah. So any other questions? Anyone has any other questions?
No, sir.
Guys, if any questions, you can ask. Otherwise, we will conclude the meeting.
I think that was it. This actually was a really great webinar. In just few minutes, I got to learn a lot. Actually,
I think
thank you,
so.
sir. Thank you very
Thank
much
you.
for coming.
Thank you.
Yes, sir. This session really provided some very great insights about using blockchain in intelligent vehicles. I have only heard about
Yeah.
using blockchain in cryptocurrencies and smart contracts,
Yeah.
but this was like a whole new field.
Thank you. And yeah, of course, is
And
just intelligent vehicles is not the enough. Is still they have a blockchain. Currently, you can see the real estate. They are using to blockchain network.
Yes, sir. They're using the
Blockchain.
yes,
escrow
sir.
contracts for that.
So in
Yes,
upcoming
sir.
year,
To
you
save
can
the
say that
informations.
yeah, upcoming year you can say that blockchain can be more important than to others, like similar as to machine learning and artificial intelligence. The blockchain is also same as for them things. Yeah.
Like there will be the decentralized apps regarding it.
Yeah, decentralized app can be, you can divide, you can, decentralized app is simple, you can create your own self. Anyone can be create the platform of the Ethereum and Solana
Yeah.
and the another they are providing to that type of platform. You can create your own blockchain network. You can create your own and make it your own group.
Yes, sir.
Yep.
I will be stopping the recording now.
Okay, thank you.